All right, so number 13. It says that the orbital radius of Europa is 671,000 kilometers. So I think we're talking about that distance. Uh-huh. You have to convert it to meters. That it?
I think that might be it, and then you just do the 2 pi r over t in seconds, and then you get the...
I don't know how you did it, but you could have. That would be a way. That's probably not how I did it, but do I need to continue this one? All right. I would do it this way. There's a force on this planet, or on the moon in this direction. That force is causing centripetal acceleration. That force is caused by the mass of Jupiter times the mass of Europa times g divided by their separation distance squared. And that has to equal the mass of, we're going to say Europa is the thing that's orbiting. Velocity squared divided by r. And then I'm going to remember that velocity is equal to 2 pi r over the period, because they gave us the period as 85 hours. And so I'll do this substitution and get mass of Jupiter, mass of Europa, g over r squared, equals mass of Europa times 2 pi r over t squared over r. All right, that's everything. And I'm not doing this substitution stuff for my health. I'm doing it because you have to be able to do it. You're going to pass tomorrow's test. This kind of stuff you should be able to do. It's not all on the equation sheet. But if they ask you to derive a relationship between the period and the radius, you had better be able to do it. I've done it several times in front of you now. So I'll cancel out the mass of Europa. And although I could go ahead and cancel one of these r's, however you decide to do your algebra, you should do it. But just make sure you're doing it correctly. This gives us 4 pi squared r squared over t squared. Now, cross multiply, mass of Jupiter, g t squared equals 4 pi squared r cubed. We want the mass of Jupiter. So again, r 671,000 times 10 to the third meters, because it has to be in meters. Period is 85 hours, but of course you're going to have to convert that to seconds. There you go. And I bet you get the mass of Jupiter now. Yeah. All right, so there's a whole variety of things that are being asked here. All of these are necessary for your test, so you should be able to do all of them. So let's talk about the first one. Find the velocity of the moon around the Earth. Again, I'm going to start with the first principle. Net force equals mac. So there's a force of gravity acting on the moon from the Earth. I'm going to say this even though it's not really true. But let's go ahead and assume the mass of the Earth is much bigger than the mass of the moon. This will make the radius of curvature the same as the separation distance. Now, we're not going to be able to do that forever. Eventually, we're going to have to realize that that's really the radius of curvature, because that's where the center of mass is. But we'll save that until next semester. All right, so let's see. Mass of the Earth, mass of the moon, g all over separation distance squared. It is the moon whose velocity we are interested in, so I'll put the mass of the moon there. v squared over r. Divide by mass of the moon, multiply by one of the radii, and take the square root, and this will give the velocity of the moon around the Earth. It's moving, isn't it? I mean, it's fast. You know, kind of silly, but you know, you're trying to aim a rocket at it. You don't really think about how fast it's going, but it's not slow. Again, the next question is to remind you that there's no weightlessness. You're experiencing weight. Even the moon is experiencing the acceleration due to of gravity to the Earth. To get that one though, we could have stopped right about here to get that one. Mass of the moon, mass of the Earth, g over r squared equals m of the moon times a. You want this. This is what you're looking for, the acceleration of gravity on the moon from the Earth. So just cancel out the mass of the moon, and that'll do it.
Thank you.
You're welcome. Is that enough? Okay. The rays of curvature of both the dip and the hill are given to be the same. Let's see, 50 meters. So this is the rays of curvature, and it's 50 meters. And over here, rays of curvature, that is 50 meters. And car's traveling at a speed of 22 meters per second. Is that right? Yep. Over here, traveling at a speed of 22 meters per second. All right. These represent circular paths. So the only way the car can successfully make it through a circular path is if the net force acting on the car is equal to MAC. So although the car's speeds aren't changing, the direction of their path is changing. We're looking at the very bottom and the very top. There are two forces acting on the car here. There's a normal force up and weight down. The normal force has to be greater than the weight. It's the only way the car can successfully change the direction that it's traveling. If the normal force is equal to the weight, the car would just travel in a straight line and tunnel through the ground. That's not what we want. Similarly, this car is going to have the same value for the weight, but it's going to have a much smaller normal force, so that the unbalanced force is downward, so it can make it through the turn. So again, that's why you feel heavier at the bottom of a roller coaster curve, and this is why you feel lighter at the top. So let's just pick one of these to start with. Since net force equals MAC, I make the positive direction the direction towards the center of the circle. And I'll get normal minus mg equals mv squared over r. We're looking for the normal force. So normal equals mg plus mv squared over r. There's numbers, and a numerical answer is sought after. The other one, I'm going to make downwards positive. Towards the center of the circle, you make that positive. So mg minus normal equals m v squared over r. So that's going to be normal equals mg minus m v squared over r. So I mean, it's going to be very similar, except you're changing that from a plus to a minus. And if this becomes 0, you're airborne. So you want to be touching the ground. Is that enough? For how to do this, you need one. I've given you one method. I will encourage you to understand that I don't have to make this about gravity. It can be about anything. It could be centripetal acceleration. It could be net force. You just pick your function. Any of these kinds of problems are usually based on a specific function. So you have to know which function they're dealing with. This one says two objects, mass M1 and M2, experience a force of gravity of 10 newtons. All right, so mass M1, M2, G over R squared experiences a force of 10 newtons. They gave me the function and they gave me the value. Now they're going to change stuff, and they wanted to find out what the new value for the force is. There's a lot of ways to do this kind of problem. There's the ones like this where we're just told that one of the qualities changes, and you're supposed to figure out how that affects the answer. So that's the first couple. Let's do those, or at least one or two of them. It says the distance is doubled. All right, so I'm assuming they mean the separation distance, R. So M1 stayed the same, M2 stayed the same, G stayed the same. I'm rewriting the function, but I'm putting the value of the change in there. They said that R doubled. So the first thing I would do is rewrite the function, put in the change. Once you have the change, pull the numbers that you added to the left and the variables to the right. So what I mean by that is I have 2 squared. I'm going to pull that to the right. And I'm going to put everything else to the left. When you collect everything else, it should be the function you had at the start. So replace it with the value. This is one way to do these. There are several other ways, but this is the way that I'd like you guys to do it. And that's what we talked about a couple weeks ago. Yeah?
How'd you get 1/4?
2 squared? All right, so in the denominator here, it is 2r squared. So that's 2 squared times r squared. And 2 squared is 4. So that's m1 m2g over 4r squared. So I'm just pulling the 4 out. So 1/4 times m1 m2g over r squared. Is that okay? It's in the denominator, so I have to maintain that. All right. The rest of these are largely the same. Do you want me to do, I think A and B and C are all the same. So I would just, so A, I could put in a 3 instead of a 2. And then when both masses are doubled, okay, so it'd be 2m1 and 2m2. It's the same kind of thing. D is different. What is the new distance to cause the force to be cut in half? So that changes this up a little bit. So I think that's worth exploring. All right? So again, we know that m1 m2g over r squared equals 10. Now, here's where it gets a little harder. It says m1 m2g over a new r squared equals 5. Okay, so we need to figure out how to get what the new r has to be. There's a couple different ways to do this one. Now here they've changed the result. So we don't know what number to put here to make that happen. No, but we could do it this way. I'm going to show you 2 different ways to do it, okay? Here's way number 1. This is the way that is most like what you just did. First, can you figure out what you have to do to 5 to make it look like that number? What do you have to do to it? Double it, right? So, be careful. You want to double it. So we know 2 times 5 will give us the 10, right? So here's how I would consider that. I guess I did this the wrong way. Let me say this a little different to help you understand what I'm doing. What do I have to do to this to make it look like that? I have to cut it in half, right? All right. So this equals half of 10, right? But 10 is m1 m2g over r squared. okay? So cut out all the middle stuff, and I get m1 m2g over r new squared equals 1/2 m1 m2g over r squared. Now we want r new. We want to know what it equals. So you're going to get a bunch of stuff that's going to immediately cancel out. And just do algebra to get Rn by itself. I'm going to cross multiply and get 2r squared equals Rn squared. And then take the square root of both sides. This is a method for how to do this. Again, this works best if there's an easy way to convert that number to the other number. So let's practice this method again, and then I'll show you a different method. I think the other method is harder for most of you. So let's try this method again. We'll just change the problem though. Let's say instead we want the force to be, I don't know, give me something, 50? Is that okay? So we want to find a new distance where the force will be 50 newtons. All right, so I'm going to tell you guys what to do. You do each step. First, can you figure out what you have to do to this number to make it that number? If you can, write it. Now, your next step is to sub in for this number your original expression. Go ahead and do it. Now cut out the middlemen and set the two beginning and ending things equal to each other. And solve for Rn. Pretty straightforward. There's another way to do it. Do you want to learn a different way to do it, or is these sufficient? That's good? All right. We'll stick with that. So, anyways, that's the space station question number 11. The biggest thing is making sure you add the altitude to the radius of the Earth in that one. Allie, you had your hand up?
Oh, okay.
All right. All right. So if there's no more questions, I'll describe to you. Yes, Nathan?
Can we also do number 14?
A spaceship mass m is in a circular orbit about a planet mass m, a distance of 2r, where r is the radius of the planet. The ship decides to move to a higher orbit of 3r. What is the ratio of the new linear speed to the old linear speed of the spaceship? Which is why I was surprised. And why sometimes I don't like to give the answers, but I did. There's the original radius here, which is like 2 times r. And then there's another radius out here, that's 3 times r. These aren't going to be perfect, but I'll do my best. So we've got r 2r, 3r. And the this is the velocity at 2r, velocity at 3r. This problem, it wouldn't matter whether I asked about the period or the velocity or even the acceleration. You need to come up with a function that describes the velocity as a function of the radius or the separation distance. And the other one this is very similar to question number 15, except in question number 15, you have a function already. In this question, you have to create the function. So we've done this one already, but I'm willing to just speed through it again. This is how we get the velocity as a function of the radius. Now this is just the relationship. Our actual velocity for at 2r would be the square root of MEG over 2r squared. Right? Yeah?
Did you cancel out the square root? Did you cancel out the r?
Oh, that's squared, you're right. The velocity at 3r, square root of MEG divided by 3r. Now they want the ratio, I think. So remember, which ratio to what? What is the ratio of the new linear speed to the old linear speed? All right. Our ratio is a fraction. So V3r divided by V2r. That's my ratio. Of course, they want all of this divided by all of this. So it's going to be a lot. MEG over 3r divided by MEG over 2r. Now, math is going to have to math, and you guys are going to have to math. But I'm going to separate out the numbers from the parts that are the same. I see over here a square root of 1/3 and a square root of 1/2. And I also see the square root of MEG over r and the square root of MEG over r. I'm just separating out the parts that are all the same because this is just 1. Right? It's all of the same stuff divided by all of the same stuff. That leaves me with square root of 1/3 divided by the square root of 1/2. I know there's people who have trouble with this, but you're going to have to just figure that out. I'm going to help a little bit. It's all one big happy square root. And then I have 1/3 divided by 1/2. I want to make that not a compound fraction. So I'll just multiply top and bottom by 2. Right? And that'll give me the root of 2/3. So that's V3r to V2r. So when you're at the other orbit, you have to do the square root of 2/3 the velocity to be there. Now, by the way, could have just as well asked you about the ratio of the periods. It would mean going a step further. And we've already done all the work to get here, so I'm not going to rehash it, but mass of the Earth, G T squared equals 4 pi squared r cubed. Does that look familiar? So you could have that where I wanted the ratio of the two periods, and it'd be the same kind of problem. You have to come up with the function first and then use the function. And it could be the same as like question number 15. but you have to come up with the function first and then show how changing one thing changes the other. And of course, I'd probably change the radius. Why? It's under the cube. It's to see if you understand that it's cubed. It has a bigger impact. All right. So the first thing you had to be able to do was deal with the forces acting on it. So I say to you, draw a free body diagram, and there's only two forces. There's tension and there's weight. They are unbalanced. They have to be. This thing's traveling in a circular path. And the only way it can travel in a circular path is if the net force on it is unbalanced. So the path looks something like that. It's traveling this way. When I look at this, I want to remind you that net force equals MAC. So I'm going to break this up into the X direction and the Y direction. So far, all of this is dynamics, which I want to retest you on. I want to have more of these kinds of problems on your test because we know this is tough. I'm going to say the net force in the Y direction equals 0. There's an angle here, theta, that makes that angle theta. And doing my geometry, it looks to me like this will be T cosine theta, and this will be T sine theta. So I see T cosine theta minus mg equals 0, or T cosine theta equals mg. Over here, I have T sine theta equals MAC. Well, this is how you're going to figure out what the acceleration is. You need that, but you also need to figure out what this radius is, because that's here. All right. To draw a free body diagram, and there should have been just two forces here. Tension in this direction, and weight in this direction. This has to be unbalanced. The object is traveling in a circular path, so you have to have an unbalanced force to cause a centripetal acceleration. So it should be clear from your diagram and from what you're about to do that you have an unbalanced force. The object's traveling in a circle that looks something like that, with its velocity kind of three-dimensionally coming at you here. In order to break this up, I'm going to choose a coordinate system that has a component that is directed towards the center of the circle. That's what you need. We want to make sure that we have our acceleration pointed towards the center of the circle. So I'll have this be my X direction and this be my Y direction. The tension is going to be broken up into two components. A component along the Y direction and a component along the X direction. Doing the geometry, this has got to be 30 degrees, which makes this component T cosine 30 and this component T sine 30. I'm expecting that at this point you guys can do your trig. Now, here's where, again, I give you a lot of information in the problem, but I probably wouldn't give you this much on a test. I would expect that you guys could make these kinds of deductions. Understand that's the X direction where the acceleration is, and the Y direction is balanced. So in the Y direction, that gives me T cosine theta minus mg equals 0. Well, in the X direction, I have T sine theta equals mv squared over r. Now, there's several things that have to be done here, But if we're eventually trying to figure out the period of rotation, then we're probably going to need to use something like this to figure out the period of rotation. It's not the only way to do it, but it's the likely way to do it, which tells me I'm going to need to have the velocity. Well, I'm thinking probably the best way to go is to use my force equations to get the velocity. I don't know what the tension is, but I think I can eliminate tension between them. We've done problems like that before. So I'm going to start by solving this for t cosine theta, and taking it over here and canceling out the tension by dividing both sides of the equation. Again, we've done this before. So the left side's going to be tan theta. And the right side, the m's cancel out, but I do get v squared over rg. Now, we don't know what r is, but in the problem I tell you how to find r using the length, or at least I suggest that you take a moment and look at the triangle that's there and find r using the length. If you don't know the triangle I'm talking about, well, all right, there's a triangle like right there. This is r, this is the length of the string, and this angle is also 30 degrees. So r has to equal L sine theta, or 30 degrees. Now I'm gonna bring all of these pieces together, and you know, I haven't put any numbers in there. I know you guys like putting your numbers in early, but I see no reason to do that. So tan theta equals v squared over g times L sine theta. Nothing special here. We have theta, we have L, we have g. So we can multiply all those things out to find out the velocity. So I'll pick on one of you. You have 30 seconds to produce me a number. Yeah.
How did you know to divide t sine theta by that part by t cosine theta?
I'm trying to eliminate t. I didn't have to do it that way, but I'm trying to find a way to get rid of the t because I don't know what t is. So what I'm really doing is I'm going, all right, t equals mg divided by cosine theta, and I'm subbing that in for t here. I'm just doing it a different way. Is that okay? So I can call on anybody? Wait, I had to make sure that some people had a little bit elevated level of concern. So, what'd you get, Ben?
I got 5.57.
Did anybody else get 5.57? Nobody's backing you up.
No, I think it's wrong.
Hannah, what'd you get? Yeah.
I got 1.44.
Anybody backing up 1.44? Wow. Everybody has the same numbers and is getting different values? Oh.
I changed my answer.
To what?
I got 1.2.
1.2?
Yeah.
Anybody get 1.2?
No, I'm right. I'm 100% sure of that.
Square root of 10 times 0.5, right? The string is 0.5 times tangent 30 times sine 30 Your calculator in degrees, right? Because these are all degrees. Just point to your numbers I walk by. I want to, well, that was at least enlightening. So 1.2 meters per second. Feeling a little more confident in our work here. Still, I counted 6 answers before I made it to the 3rd row. So, eek. Once we have that, it's a pretty quick trip to get the period. So, let's go ahead and get the period here. So 2 times pi times 0.5 times, it's the sine of 30, so it's just 0.5 again, all divided by 1.2. This will give you the period in seconds. Yeah, nothing wrong with this problem. This is clearly a test question. It's completely aligned with what we did in the last unit and this unit. And the fact that so few of you attempted it bothers me. But there's every reason to believe this will be a great test question. I'm afraid the reason most of you didn't attempt is I didn't put the answers out there. But this is all it is. Okay? Just more or less to prove to me that you did some of the problem, which I believe you did. The record's spinning at 45 RPM. What is that in radians per second?
0.471.
I think that's really slow. Are we sure it's 0.471? All right, everybody, take a break, walk around. We need this angular speed. Now, the bug sitting on the record, we're trying to figure out where the bug can sit if the coefficient of friction is 0.4. We did the problem earlier. You found that the required coefficient was 0.2, so we know he can either be spun faster or he can be further away from the center. So let's see how that plays out. There are 3 forces acting on the bug. There's friction, weight, and normal force. I'm drawing this from the side as if we're looking at the bug from the side, not from the top. The frictional force is this way. And it is the frictional force that is causing centripetal acceleration. So friction equals m v squared over r, but v is equal to omega times r. So we can write this as friction equals m omega squared times r. Now there's different ways to write the centripetal acceleration. You should know them both. So this one's going to be easier for us because we have the angular speed of the record and the bug is on the record. So I'm going to prefer this way. Friction has to be less than or equal to mu times the normal force. This is static friction. So if I want to do this the way that I tend to prefer, that means to try and preserve the inequality. I don't do that too much with you guys, but I'm going to do it this way, which means instead of substituting in this direction, I'm going to substitute in that direction. So I'm going to put m omega squared r where the friction was. I know that the normal force has to equal mg because the net force in the y direction has to be balanced. Now we're just solving this for r. So the mass of the bug doesn't matter. So r has to remain less than or equal to whatever that value is. So somebody told me that the answer key is wrong. Could be. I get that r has to be less than or equal to 18 centimeters. So if the answer to you says 85, that's probably wrong.
Sorry.
Do you have a method for doing these problems?
I'm supposed to. It's in the notes, but I didn't understand what I wrote down.
All right. Folks, I would encourage you to have a method for doing this. I can give you a method, but this is on your test. So when I looked at your work, I saw that many of you do not have a method. I have given you a method, and I'm going to help you with a method, but if you don't have one yourself, it's pointless. There's a lot of variation in how these problems can be asked, and they're just ratio problems. So I'm going to show you the method I showed in class. And this method works for A through C when one of the parameters is changed and you're asking about how it affects the result. You have to modify it for D and E. You'll have to do both on your test. But I would expect that these will be multiple choice questions. And trust me when I say that you tend to think of the way you do multiple choice is kind of funny, but I know the kind of mistakes that are made for these, the way in which you tend to invert or do ratio problems incorrectly. So the wrong answers will look right. Let's start with what it tells me. It says that M1 and M2 at their current separation distance are experiencing a force of gravity equal to 10 newtons. It says the distance is doubled. We're supposed to find out what the new force that they experience is, and then tripled and all that kind of stuff. So let's just do the first one. How I would have you do these is to write out the formula, putting in place what has changed. Again, if you want to study tonight, don't just write down what I'm doing. Give yourself an instruction on what you had to do to get that written down. The next step is to separate the numbers from the original portions of the function. I'm going to pull the numbers to the left, and I'm going to put the letters to the right. Doing this in 2 steps because somebody in the other class didn't know where the 1/4 came from. Okay? Now, when done correctly, the original function should appear, and you have a statement for the original function already. Substitute in your statement for your original function. Okay?
Can you say that again? You're supposed to substitute what?
You have a statement for your original function. By pulling out these, you have something you can sub in for your original function. Okay?
So when I was doing it last night, I kept trying to multiply both sides by 4, which obviously increases the force instead of decreasing it.
Mm-hmm.
How come that seems to work, mathematically, but doesn't give us an answer?
I'm not sure what you would be multiplying both sides by 4. Like, what would the purpose of that be?
Well, if you're dividing by 4 on one side, and you multiply both sides by 4 to get rid of it, and then add it would be on the other side now. Right, you'd have the base function with a new force.
Okay, I see why you are doing it, but I'm not taking these two things and equating them as an equation. I am progressing by doing substitution or arithmetic in each of these.
Yeah, I get that. I'm saying, like,
If I take any two of these and multiply both sides by 4, I get the same equation, but it's not solving the problem.
so like the top one, with M1, M2G, R squared equals 10,
Okay.
I would,
You multiplied both sides by 4?
yeah, because there was a 4 on the denominator when I pulled it out from R squared. And then that would give you 40n.
But this does not equal 10. Those aren't equal. This equals 10. When I double this number, this has to change because I'm making the R a bigger value. Does that make sense?
Yeah.
So you can't set this equal to 10 because only this part of it is equal to 10. Does that make sense?
Yeah, like that.
It's okay. There's other ways to do this problem. This is the way I've decided to teach you. I could teach you a different way. Yeah.
Why did the numerator turn to 1? Like, why is it now 1/4? Because I get how we got the bottom. I did that, but just, I don't.
So here to talking about going from here to here.
Just like the M1, M2G, why is it not that, like M1, M2G over 4? Why is it now 1/4?
All right, so I'm trying to get the number part away from all of these things, right?
Yeah.
Okay, so start from here. M1, M2G over 4R squared. And the denominator is 4 times R, right? I could write this as 1 times M1, M2G over 4 times R squared. Correct?
Yeah.
So I could then write this as the product of 2 fractions.
Oh, you have the second fraction.
Because if M1, M2G, then those would all be squared if I multiply them together.
Yeah. Okay.
Does that make sense?
Yeah.
Perhaps we should try this again. That'd be a good idea. It seems to be so. So let's do one that's not in the homework, but we'll stick with this. Because there are others here that we have to do. My 2 guys are experiencing a force of mutual gravitational attraction equivalent to 10 newtons. However, we increase the distance they are separated by a factor of 4. So they are now 4R apart. And this guy ate a lot of pizza. So he's now 2M2. What's the new force of mutual attraction? So I've changed 2 parameters. First step, start with your initial condition and your initial value. So this equals 10 newtons. Second step, rewrite your formula, putting in place the changes to each variable. M1 didn't change. M2 doubled. G didn't change. R got 4 times bigger. instead of using equal signs, I'm just going to do progression downwards to not show that I'm making equations, okay? So the first thing I'm going to do is start to pull the numbers to the left and put the letters to the right. Separate out the numbers. I'm going to remember what the original value was and substitute it in. And then reduce it to get my answer. Everything all right? All right, so question D and E do something different. And you need to be prepared to be flexible. In question D and E, they don't change, they don't tell you what the change in the parameter is. They tell you what the change in the value is and ask by how much a parameter has to change. They say, what distance would I have to place my astronauts apart for them to experience a force of 5 newtons? We have a new R, but we don't know what that R is. So I rewrote the function and put an n next to the variable that changed. And I set it equal to my new value. Everybody see what I've done? Now, here's the method that I would like you to try. Ask yourself, what would you have to do to your original number to get your new number? What would I have to do? I'd have to divide by 2. So rewrite this as 10 divided by 2. Everybody see what I've done? They're equal. Half of 10 is still 5. But 10 is m1 m2 g over r squared. So sub in for 10 your original function. We're just kind of doing the same thing but in reverse. So replace 10 with the original function because that equals 10. Now, cut out the middlemen and set these two things equal to each other. You want to solve for Rn. You want to solve for your parameter. You're going to get a ton of stuff that's going to cancel out. Stuff that's the same. So M1, M2G, none of that changed. That all stays the same. But now you can solve this for Rn. I'd probably cross multiply and get 2r squared equals Rn squared. And then I'd probably take the square root of both sides. and it will tell you by how much you have to change your factor in order to get that particular change.
I think we get the 2 r, yeah, the 2r squared equals 2n squared from the.
How'd I go from here to here? So let's have an intermediate step. This is 1 over rn squared equals 1 over 2r squared. And then I cross multiplied. You could invert both sides as well, but do you guys need to practice that again, or do you want to go on to a different homework problem?
Say do it again.
It's your test tomorrow. So I think we'll go on, because I heard more go-ons than do it again. So you have practice in the homework, so try those. Yep,
Could you do number 11?
I can. The International Space Station is located at an altitude of 408,000 meters above the surface of the Earth. That means this distance is 408,000 meters. But this distance is 6.37 times 10 to the 6 meters. This means that our separation distance from here to the space station, r, has to be the sum of 6.37 times 10 to the 6th plus 4.08 times 10 to the 5th. That's our separation distance. You do have to look up the mass of the Earth. You won't have to memorize any of these for the test. Anything like this you'll be given. But the mass of the Earth is 5.98 times 10 to the 24th kilograms. You were never given the mass of the space station, suggesting you don't need it. But this derivation about getting to the period, you should be able to do it. Talked a lot about it in the other class, but this is the first time it's being brought up here, I think. But net force equals MAC. What's the force that's causing them to be attracted to each other? That's gravity. Mass of the Earth, mass of the space station over G equals R squared. This has to equal mv squared over R. Are these two R's the same? They are if the planet is much bigger than the space station, which is true. I'm expecting that you know at this point you could stop and solve for V. So if right here you could solve for V and you'll get the square root. And that's how you find out what the velocity is. Yep.
Would you consider moon or the planet to be much bigger than the moon as well if we're doing a problem?
That's the only problem you can do now, so yeah. Now, if you're asked to find the acceleration on the space station, you can find it here, but don't replace the acceleration for v squared over r. Just set this equal to and find the acceleration. This would be the acceleration on the space station from the Earth. These are all the questions, right? But the last one was to find the period. And to find the period, you have to bring something else to bear. And that is distance over time. You want to bring these things together. Because what you guys have not asked about, which is too bad actually, is problem number, I think, 14. And there won't be time to go over it, but I went over it in first period. Problem 14 is the same as problem 15, but you have to create your function first. I'm seeing a function that we're creating right now. I've talked to you about this a bunch of times, about the fact that I need you to recognize there's a relationship between the period and the orbital radius. And this is how you get to it. Cancel out these. We cross multiply. This is a created function. And this is for the Galilean moon problem, the International Space Station problem, but this gives you the period from the radius. This is also one of those problems where I say, if you change the radius by a factor of 3, how does that affect the period? Or you have a period of 2 days, and then you move to a new radius, and now the period is 3 days. By how much did the radius change? Are you hearing the same questions we just did? But you had to come up with a function ahead of time. There's no reason why that couldn't be your test question. That moves it from a multiple choice questions to an FRQ. Either way, when you found the velocity here, you could have gone right here to figure out the period, or you can come up with a relationship that relates the period to the radius. I expect you to be able to do this tomorrow.